This week's reading was about decision structures, so I'd like to talk a little bit about that in this video. Okay, Chapter 4. We have a number of topics that are related to decision structures. A quick overview here of these topics. We have some new statements that we're learning about. In fact, this chapter is mostly about actual Java statements that allow us to do branching or make decisions in our Java program. We'll talk a little bit about more about what that means later on. We've got the if statement. We've got the if-else statement. We've got the concept of nested if statements, the if-else if. We've got logical operators that allow us to make decisions, and we have the concept of comparing string objects that we'll get to. So we also have some details about variable declaration scope, conditionals, other statements like switch, printf, and the decimal format class. We'll be touching on a little bit more about those in the second video of these two. So the first statement that gives us the ability to make decisions in Java is called the if statement, and most languages will have an if statement, or at least some way of performing the same purpose that an if statement serves. And that purpose is the if statement decides whether a section, we've talked about blocks of code, the if statement decides whether a block of code executes or not. So you have the choice in every program of having a block of code that only executes under certain circumstances that you, the programmer, decide. So the way if statements make this decision, notice that there are two choices here. The section of code executes, or the section of code does not execute. Those are the two choices. So the if statement uses a Boolean to decide whether the next statement, or the whole block of statements, executes. Remember that the Boolean has two values, true or false. And so these are the two options, the two alternatives. In one case, the section of code will not execute. In another case, it will execute. And so here you see the form, and this is kind of a pseudocode form, but it's also what Java code looks like here. But this is kind of when you see an if statement in an algorithm, it looks like this. If, and then in parentheses, some Boolean expression is true, then it will execute the next statement. So imagine that you have an algorithm where you, which is about how to get from your car in your driveway through the door into your house where you live. So in order to do that, you might have to open the car door, step out of the car, close the car door, lock the car up, walk to your front door where you live, and then when you get to the front door, you might say, well, there should be an instruction that says unlock the front door. However, it doesn't make sense to unlock the front door unless it's locked. So perhaps you would have some kind of a check that says if door is locked is true, then unlock the door, and then you can go on with the rest of the algorithm, which would be to open the door and walk through. So what would happen is if you were executing this algorithm yourself, then you would walk up to the door, and then you would check if the door is locked, and if it is locked, you would unlock it. And if you check if the door is locked and it's not locked, then you don't unlock it. You would just then do the next step, which is to open the door. In both cases, you do the step of opening the door, but before you do that, you have to decide whether it needs to be unlocked, and then you unlock the door. So hopefully that's clear. Basically, in any algorithm that has branching, you get to a point where you check some condition, and based on that condition, you decide to do something, a certain thing, or to not do it, and go on with the rest of your algorithm. So here we have a representation that's called a flowchart. which gives us a way of visualizing how an if statement works. A flowchart is useful because there is a flow to algorithms. We've talked about what an algorithm is before, a step-by-step process for accomplishing some task. And so those steps flow one to the other, and that's the concept of the flowchart, allows us to see that flow progressing. So here's a little bit of a flowchart that shows branching. Okay, and we've got a kind of a pseudocode representation over on the left side of our algorithm, and then we've got the visual flowchart representation on the right side. So let's compare them here. So this one says if, and then we check the condition cold outside, and if this is true, it's going to execute the statement where coat. So that's what this Java code does. If cold outside is true, then where coat. So we can imagine that cold outside must be a Boolean variable, and where coat is a method of our class. Okay, so if cold outside is true, we are going to execute where coat. So how does the flowchart work? Well, we imagine that we're coming in to the decision, and this diamond represents a decision. Okay, so the decision has two ways that it can go. The question is it cold outside? If the answer to that question is yes, then you follow this branch, and this branch takes you to the command to wear a coat. If the answer is no, which is the only other option, there are only two options, then it flows forward to whatever the next set of statements would be. And notice that, so as I said, there are two branches. That's why this is called branching. In the yes case, we go off here and we do something. In the no case, we don't do that thing. But in both cases, we eventually meet up to go on with the rest of the program. That's important because the program has to flow from the beginning to end. So you take a little bit of a detour to do certain things, but then eventually you meet up again and you continue on. So in our previous example, in this example, this if statement just does one command if the condition is true. If we use these punctuation marks, the curly braces, we can define a block of code, and then the if statement will execute that entire block of code if the condition is true. It will skip over the entire block of code if the condition is false. And here we see that happening in this flowchart. Is it cold outside? Yes. Then we will go one by one through each of these statements and do all of these commands. All of these statements will be executed, and then we eventually meet up and go on. But if it's false, if this condition is false, we just go straight through. And we skip over all of these because these are all in the same block of code. So the if statement, the consequence of the if statement always pertains to the thing that comes next. That thing can be a single statement, or that thing can be a block of code, and that just depends on how it's punctuated. Okay. So inside of the what I like to call the conditional of the if statement, there is something that must evaluate to a Boolean. So it must be able to be evaluated as true or false. Cold outside, for example, can be thought of as the question, is it cold outside? So this variable must be a Boolean here. Okay? But often, in fact in most cases, you won't just have a single value in those parentheses. You will actually have some kind of an operation, which is probably a comparison of some type. And in Java, we use these relational operators to compare values. Okay, and those values could be, let's imagine for a moment that those values are integers. So you probably are familiar to some extent with these symbols, but let's go through them quickly. So if you have, these are binary operators, meaning that there are two operands, one on either side of these operators. Okay, so if they were ints, is greater than checks if the int on the left is greater than the int on the right. And if it is greater than, then the result of this comparison would be the Boolean value of true. This is less than. So if the int on the left is less than the one on the right, this would be true. Otherwise, it would be false. We can also include that value in the comparison. So if the int on the left is greater than or equal to the int on the right, then this statement would be would be a true comparison. Otherwise, it would be false. Less than or equal to works the same way. We do equals with two equal signs together. Notice that this is very important because we use the single equals as an assignment in the Java language. So to distinguish this from an assignment statement, we use two equals. Okay, so if int on the left is equal to int on the right, then this would return true. And then we have an option to negate the equals. So is not equal to is an exclamation point and an equal sign. You'll see these in action. Here are the examples with the operands placed in there if x is greater than y. So all the examples we just went through, this is what they look like in practice with two variables. And here they are in actual Java code, and this is what they look like, and this is what you'll see when you find them in programs, when you write your own programs. So the conditional itself is within the parentheses after the if statement. So if x is greater than y, then what are we going to do if this is true? We're going to execute this statement, okay, which happens to print something out to the console. Okay. If in this case, so let's say x is 5 and y is 3, then we would, when we got to the statement, we would execute this because 5 is greater than 3, and then we would print out x is greater than y. What if x was 3 and y was 5? Then 3 is not greater than 5. We would just completely skip over this statement and we would go to the next statement. Okay? So these examples work similarly. This is comparing to see if they're equal, and this is comparing to see if they're not equal. So this example is a little bit different because instead of a single statement after it, it shows how you can have a block of statements that are punctuated by the curly braces. And this refers to an example that's in the book. So we have certain conventions that we follow when we use if statements, but the compiler allows you to have some flexibility in what you want to do. For a short if statement, you can write it like this. You can say if, and then you can put the conditional here. Then the statement that's going to be executed, you can actually just place it on the same line next to the conditional, just like this. This is perfectly legal Java, and this is fine for for a small if statement that fits on a line. You can actually do this. However, most of the time you'll see it like this because people will place the line to be executed after and then on the next line, and they'll indent it a little bit, and that just really highlights. It allows you to kind of, as you scan down the page, to skip over this to realize that this is a kind of a sub part of the if statement. It depends on the if statement. And that structure at a glance helps you understand the program. So these are equivalent, but generally you will see me writing programs in class like this, and I think your programs will be more understandable and readable if you adopt this approach to if statements. However, I do acknowledge that they are functionally equivalent, which means the compiler will treat them exactly the same. Notice that there's only one semicolon in each of these cases, because an if statement doesn't count. This part of the if statement doesn't count as an entire statement. The entire statement is everything together, you see? Okay, and that's true as well for this block of code. This is treated like one statement that contains a block of code in it, which of course is made up of statements. Okay, and as we saw in an earlier chapter, you don't actually have to put a semicolon after a block of code. The curly braces begin and end. That is enough to tell the compiler that this is the beginning and end of a set of statements, and so they don't need an additional semicolon. So we follow some rules of thumb to make our code more readable and execute smoothly. And as I said, we put the statements on a second line just for readability. We indent it, as you saw before, like this, and that aids the eye in scanning down, knowing that this will only execute if the if statement's expression, Boolean expression, becomes true. And we don't use semicolons here because this is really considered one statement. There you go. And we discussed this. Okay. So this can be a little misleading. So notice the way this is formatted, and note that Java, the formatting, is really for the purpose of making it easier for programmers to read. The formatting is largely ignored by the compiler. We indent things to show that they are dependent on other things, for example. In this case, however, we have some misleading indentation. Okay, why is that? I'll let you think about it for a second while you look at it. Well, the answer is actually here already, but think about why that is true. The if statement always executes, always pertains to the next executable statement. So if you say if expression, this is your Boolean expression, if this is true, then it's going to execute this. If this is false, then it's not going to execute this. So the if statement has nothing to do with these further statements. Okay? If you wanted them to be part of the if statement, you'd have to put them in a block of statements. You'd have to put them in curly braces. Okay? But since they're not in curly braces, the if only pertains to this first statement. So to be formatted correctly, these statements should be actually over to the left because they aren't part of the if statement. Okay, so that is how, well, that is an example, looking at it again, that is an example of how code can be formatted in a very misleading way. Okay? But the compiler doesn't care. The compiler is going to ignore that formatting. So sometimes we make Boolean variables in our programs in order to store the value that is generated from doing a conditional operation. Okay, so in other words, we can compare two variables to see if one is greater than the other, and we can store the Boolean that results from that comparison in a Boolean variable. We call that type of a variable a flag, especially when it's used to monitor a condition in a program and actually govern the execution of parts of code in the program using if statements. So looking at the third bullet here, the flag can be used later on once it's been created. So for instance, let's say we test if average is greater than 95, then we consider that to be a high score. So we set high score to true. So this is a Boolean variable because it can be set to true. And then sometime later on in the program, basically we've already stored that this condition is true, and then we can use it whenever we want. So we can have another if statement later on. We don't have to make this comparison anymore. We can use the high score Boolean variable and just say if high score is true, so if high score, then execute this line of code. Okay, so that's, now we see practical value for Boolean variables because we can store the results of conditions in those variables for later use, just like we store the values of integers for later use. Individual characters can also be compared just like numbers are compared. The relational operators work because deep down in the code, Characters, as we discussed in class, characters are actually just integers. They're stored as integers, a 16-bit number in this case. There is an order to the characters, and if you look at an ASCII table, which I'll place a link to an ASCII table in the resources of the course to allow you to look at the ASCII table. The ASCII table is what will determine whether one character is larger than another. A character that is later in the ASCII table is larger. Same is true for Unicode. Unicode is, I'm sorry, we are using the Unicode standard here. So in the Unicode table, it's also true that the characters that are later in the table are considered to be larger. So let's say we have a char C, and we set that to capital A. Remember that capital A, it's important because that's different from lowercase a, just to keep that in mind. Later we compare C. We ask, is C less than Z? Well, because it comes before Z, then this will be true, and we can print A is less than Z. So characters can be compared. There's an additional structure that we can add on to the if statement that allows for a second condition, for a second statement or block of statements to be executed if the condition is false. So before, what we had was we had an option to execute a statement if a condition was true and just skip over that statement if the condition was not true. Now we have an additional option of two separate types of statements, two separate blocks of statements possibly, that will either be executed, either of them will be executed depending on whether the value of the expression is true or is false, which means nothing is actually getting skipped over. Instead, it's the alternative between two statements. And here's what that looks like in a flowchart. It's actually easier to visualize like this. So as I said, nothing's being skipped this time. Instead, you just kind of have two alternatives. So you've got, if it's cold outside, yes, you wear a coat, and then you continue on. But if no, then you wear shorts. So if no, you don't wear a coat, you wear shorts. If yes, you wear a coat, you don't wear shorts. But instead of a skipping type of thing, you have basically a choice between two things, two separate things. One of the ways that ifs are made useful for more complex situations is that you can put if statements inside other if statements. And if this sounds like it could get a little confusing, actually you can write some fairly confusing code using lots of nested if statements. And it is possible to write confusing code. However, it's also very necessary to write nested if statements for many situations, because in some programs there are many different conditions that can be true or not, and those conditions can control what's going on in the program. The interesting thing, well, one interesting thing to note about nested if statements is that you may never get to the statements deep within a nested if statement if the outer if statement isn't true. I mean, that's just the nature of having nested if statements. So they should be read or evaluated from the outside in. And this slightly more complex situation is modeled with this flowchart. As you see, you're coming in, you've got the first or outer if statement. And in this case, it's saying, is it cold outside? And this must be an if-else statement, because instead of a skipping type activity, we have an alternative between two things. So one of the alternatives is, if it's no, you just wear shorts and you go on. But if it's yes, then you go straight to another if statement that's asking, is it snowing? And if that is yes, then you wear a parka. You can see through this that there are different paths through the flowchart depending on these two values. you can actually count the number of paths. If you look from left to right and kind of draw a line, you can see how many different paths you could follow by what paths the line would break. So in other words, you have 3 different alternatives. Even though you have 2 questions, you have 3 alternatives. You may end up wearing shorts, you may end up wearing a jacket, you may end up wearing a parka. Okay? And those are actually all separate because you will never be wearing shorts and a jacket or parka. And the way you can test this or show this is to actually take a trip through this flowchart. In one case, you may go through here and you end up wearing shorts. In one case, you go through here and you end up wearing a jacket. And in one case, you go through here and you end up wearing a parka. So those are the choices. There are 3 different things that happen. So the reason that's important to note is because when you think about a problem that you have that you're trying to solve, and you notice that there are 3 different alternatives, then you know now by looking at this that the approach that you should take in solving this problem is probably to use a nested if, because there isn't a structure right now that we've learned yet that allows you to handle 3 different cases, but you can handle 3 different cases by using the if, else statements and structuring them in a nested way. This is what that looks like in Java code. So you have the outside if, the outermost if it's cold outside, and notice that you're going to execute a block of code if that is the case. Okay, but if it's not cold outside, you go to the else and you wear shorts and you drop out. So let's just take a quick to get used to the structure of the Java code. I'm going to look at each path through this code by going back and forth between the code and the flowchart. So let's do this leftmost path first through the code. Okay, if it's cold outside is false. We skip this entire block of code, or I should say we look for the else condition, which executes if the condition is false, and we execute that block of code. So we wear shorts. And then we go on with the rest of the program. That's this leftmost path. Okay. How about this next leftmost path? If it's cold outside is yes, then we ask is it snowing, and that's no, and we wear a jacket. What does that look like in the code? If it's cold outside yes, then that means we execute this block of code. Great. So as soon as we go into this block of code, we see the question if snowing, and we said it wasn't snowing, so we don't go into this block of code for this if statement. We go straight to the else and we do wear jacket. And this is why I'm stepping through this, because this is where it gets a little confusing. What do you do if it's else wear jacket? It looks like the next thing you do is this else statement and wear shorts. Okay? But going back to this drawing, notice that isn't the case. We drop through. That's because we only will execute this else statement if cold outside was false. These are the 2 alternatives. There's this one alternative, this block of code if it's true, this block of code if it's false. So when we got to this point, wear jacket, and we're ready to kind of pop out of this part of the if statement, we don't go to the else, because the else, we've already made a decision that we are not doing that else. So what do? We go to the end of the if statement, which is after the end of the block of code that's after else. Okay? So this is the path through here. If it's cold outside is true. We go right here into this block and we ask if it's snowing, and that was false. So we jump to the else. We do wear jacket, and then when we go here, we can't do the else because it was that was already decided earlier. So we go after that, and then we continue on. All right, what about the rightmost path? Is it cold outside? Yes. Is it snowing? Yes. Wear a parka, and then we fall out and go to the next thing. Okay, if it's cold outside, yes. Then we check, is it snowing? Yes. We keep going in deeper. Wear a parka is what we execute here. And then we get to this point, and because if snowing was true, we went in here. So we're not going to do the else. So we try to pop out of that, and we realize we're at the end of this block, and we're not going to do this else because that was also already decided. So we just go to the end of that, and then whatever code came after that, that's what we do. So you don't need curly braces if you're only executing one statement in an if. But in this example, so there are unnecessarily curly braces in this example because an if counts as one statement. Okay, so does wear shorts counts as one statement. This could have been else wear shorts with no braces. However, especially when you're beginning, it makes it a little bit more readable there. And the indentation also makes it much easier to see where you go when processing finishes one of these sets of statements, one of these blocks. Here you can see an illustration of how this indentation is accomplished and what lines up. So people like to line up the curly braces here if with its beginning and ending block all line up on the left side. And this if and else line up because they are part of the same statement. And the same is true for the inner one. This if and else are part of the same statement, and these curly braces are part of the same if statement, and so they all line up to the left. And then the statements that are executed as a result of what happens here are indented. Okay. You can actually write a structure that chains more ifs off of the ends of else's. So you can say if this expression is true, then do these statements, and then else if, and you can ask another question and then do these statements, and that can go on and on and on. Else if, else if, else if, else if, until you're done. So you can actually have many nested. They're like being nested, but it's kind of a chain. For purposes where you are kind of choosing among very many options. So you have to imagine a case where that might be true. So you check one thing, and if it's true, you do this. But if that's not true, then you check this. If that's not true, then you check this. If that's not true, then you check this. And if at any time you find a condition that is true, you do that thing, and then you don't check any of the other things. If you need to see an example of this, please ask me in class, and I can show you. As I said, these can become very complex, so we have to be careful when we are programming with them. So we should think about ways to simplify logic, and we should actually try to keep them as simple as possible. And a good reason to do that is because we may actually not be able to show other people that our programs work correctly if we don't have code that is readable and understandable. And we actually may lose track of our own understanding of how our code works in that same type of case. Okay? And here's a good illustration of that if else if structure that we saw before. And you can see how it is a little bit complex. You come in here. If score is true, then if score is less than 60 is true, you give the student a grade of F, and then you drop out. You don't check anymore. If it's true, you don't check anymore, you just drop through. But if it's false, you check whether the score is less than 70. If it's less than 70 here in this case, you know it's 60 or greater, because it's not less than 60. So you gave a grade of D, and then you drop through. But if that's false, you do the next check. Is score less than 80? If that's false, you do the next check. Is score less than 90? So you see that This allows you to skip over all of the other cases, all the other checks, by having an alternative here. But it also allows you to ask a number of questions. But this also illustrates one condition, one situation where this kind of structure actually makes sense. It's almost like sorting. It's almost like a bin where you have different sized holes. If you've ever seen a coin sorters work a little bit like this. You sort for the big coins. You have a sieve, kind of a sieve that has holes that are just small enough so that, for instance, so that quarters won't fall through, but dimes and nickels and pennies will fall through. Okay, so you capture all of the quarters, and then once you've sorted those out, you have slightly smaller holes that nickels won't fall through, but dimes and pennies will fall through. So it's that sort of thing. And that's the end of part 1 of this video. Look for part 2 of this video, which will be coming soon.